Hello, good evening, friends. Now we have our next topic, magnetism, right? What we have read up till now in magnetic effect of current, that when a current carrying rectangular loop is placed inside a uniform magnetic field, what happens? It experiences a torque, and due to that it starts rotating about an axis with an angular velocity omega, right? And that torque comes out to be NIA B sine theta, right? And in electric dipole case, what we have got earlier on, that when an electric dipole is placed inside a uniform electric field, then it also experiences a torque on it, which is given by tau equal to PE sine theta, right? This is equation 1, 2, and this is equation 1, right? Here P was what? It was electric dipole moment. Right? E angle C theta angle between that and like this only. Just in analogy to these two equations, right? Torque is there, magnetic field is there, we have got electric field sine theta, but this thing is a bit different, right? So in an analogy, what it was considered, this NIA is given a name capital M and will be known as magnetic dipole moment. Magnetic dipole moment of a magnetic dipole. Question arises, what is magnetic dipole, right? So a bar magnet is just a suitable example of an electric dipole, north south, length is 2L, just like that electric dipole we are having, right? So it considered that electric dipole, this rectangular coil, is just an equivalence of a bar magnet placed inside a uniform magnetic field, right? So the torque experienced by a magnetic dipole, that is what we have given them, bar magnet is a simple case of magnetic dipole, will be what? Tau equal to MB sine theta, just like tau equal to PE sine theta. Just by comparison we got this one, right? Where M is NIA. But if I use this bar magnet, right, what will be M for a bar magnet, right? This M should be something like this Q into 2L, right? Where Q was the charge, here nothing to do with the charge. Here we consider a physical quantity, small m, we call it pole strength. Instead of charge, we are using pole strength of the bar magnet. So this M can be defined as M into 2L, where M is the pole strength, and mathematically it is equal to NIA. Remember this quantity. And so far as unit is concerned, magnetic dipole moment, I is for ampere, A for meter square, right? Unit of So unit of magnetic dipole moment is, remember, ampere into meter square, I into A, right? What will be the unit of M? So if I say M equal to NIA, and which is equal to M into 2L, what we will get from this, that small m is NIA by a 2L. And so far as unit is concerned, what will be unit? Ampere meter square by a meter, and we will get ampere meter. Remember this frequently asked question. Unit of pole strength is ampere into meter. An objective question. For magnetic dipole moment, it is ampere meter square. For this pole strength, it is ampere into meter, right? So what we got? We got the article just like we did in case of electric dipole. Now we will use it as a fact that when a bar magnet, suppose I am having a bar magnet, is placed inside a uniform magnetic field, then it always experiences a torque that will be mb sine theta, right? For maximum torque, what we have, the only variable is theta. Sine theta maximum value is +1, I can say sine 90, right? At theta is equal to 90, that is when bar magnet is placed perpendicular to the magnetic field, 2 max will be m into v. Why I'm trying to define m also with the help of 2. So m, magnetic dipole moment, can be defined as maximum torque experienced by a bar magnet when placed inside a unit magnetic field. Remember this definition. Maximum torque experienced by a bar magnet when it is placed in a direction perpendicular to a unit magnetic field, right? This is one more format of the M, right? Now, 2 we have established. We will repeat the article. Amount of work done to rotate a bar magnet. A magnetic dipole means a bar magnet inside a uniform magnetic field. Remember, it is just an replica of the torque experienced by an electric dipole and work done to rotate a dipole inside a uniform electric field. So we will use it as a fact. What? When a magnetic dipole, that is bar magnet, is placed inside a uniform magnetic field, then it experiences a torque which is given by tau equal to mb sine theta, right? Now what is the tendency of torque? Torque will try to rotate the dipole. So the small amount of work done to rotate the bar magnet by a small magnet, small angle d theta. What will be dw? In rotational motion it is torque into angular displacement, 2 d theta. So what we have got torque is mb sin theta d theta. This is the small amount of work done. Now we want to calculate the total amount of work done. Total amount of work done to rotate the bar magnet from a limit we can adjust from theta 1 initial angle to theta 2. What will be w? Simple integral of dw from theta 1 to theta 2. Substitute the value of dw. What we will get? Integral theta 1 to theta 2 mb sin theta d theta. The sin theta is the only variable. So what we got? Integral of sin theta is minus cos theta, ranging from theta 1 to theta 2, right? And if you substitute the upper limit and lower limit, what we will get? The same result, almost same. W equal to mb cos theta 1 minus cos theta 2. If you do remember, same result was there. W is equal to PE cos theta 1 minus cos theta 2. So while dealing with this article, do read it properly. It is whether for bar magnet or electric dipole. If it is for the bar magnet, very simply you can do it, right? Special cases, if theta 1 is 0, that is initially the bar magnet is placed along the magnetic field direction. Then in that case, theta 1 is 0 and whatever angle we will rotate, that will be theta 2, right? Theta 2 will be theta itself. So what we will get? W is equal to mb 1 minus cos theta. This replica, just a revision pen. Second special case, if the polarity of a bar magnet is changed, means north become south and south become north. In that case, let theta 1 be what? 0, and theta 2 will become 180 degree. We are changing the polarity, means theta 2 will become 180 degree. So what will be W? MB cos 0 minus cos 180, right? MB cos 0 is 1 and this is minus 1, so it will become 2 MB. This will be the work done to change the polarity of a bar magnet inside a uniform magnetic field. This is the work done, right? Take. This is all about torque and work done. Then again the same way we have potential energy. Of a bar magnet. Remember, bar magnet means itself the magnetic dipole inside a uniform magnetic field, right? So what is U? It is simply the amount of work done to change the position of a body with respect to a static position, right? With respect to static position, whatever work we have to do, that will be the potential energy, right? If you do remember, W we got mb cos theta 1 minus cos theta 2, right? If I write down like this, mb cos theta 1 minus mb cos theta 2, right? And if I took cos theta 1 as cos 0, the static position, minus mb cos theta, right? So this value, this 0 value, we call it static value, minus mb cos theta. So with respect to this, whatever work is done, that will be the static potential energy. So U will become minus mb cos theta, or you can add on minus m dot b, right? Another way to calculate it, if theta 1 is taken as 0, 90 degree, and theta 2, theta. So what we will get, U is equal to mb cos 90 minus cos theta, and it comes out to be cos 90 is 0, so it remains minus mb cos theta. Question arises, why we have taken 90? Actually what happened, I do remember this value, at theta is equal to 90, U will be 0, the most stable condition. That's why we use this phenomenon. You can use either this one or this one. Anyway, you can calculate it, right? This is potential energy of a bar magnet, right? So these articles are just on the base of analogy, you can say, by comparing those articles. So some basic formulas are also there. Even they define Coulomb's law, right? In case of magnet, the force between the two poles will be m1, m2 by r square, where m1 and m2 are the magnetic pole strength, right? Similarly, if I calculate B axial magnetic field, it will be mu 0 by 4 pi 2m by r cube. B equatorial, just like that. Those articles what we have done, this will help you in numerical. B equatorial 2m, m by r cube, right? That's how we do it.